I mean, technically I can do it from whatever section, but my guess is 6-4 would be the best. Like number 12 or like the handwritten one? Like number 12, okay. Number 12 is a great problem. Sure. All right, so this is number 12. On 6-4 is on that. It's on the white sheet of paper because it didn't print with everything else. All right, so I'm looking at number 12 from 6-4. I need to solve this problem. So the first thing I need to do is try to get rid of the 1/4 exponent. And how can I get rid of the 1/4 exponent? Nope, I can't because I don't have anything in common in these exponents here. Fourth root is going to be how I undo the 4th power. But I have the 1/4 power. It's not, no, I'm not going to do that because the 4th root of x is the same as x to the 1/4 power. So I'm not going to 4th root something that's being 4th rooted. So if I 4th rooted this, that's me digging a hole deeper, right? I need to undo the 1/4 power. Dividing by 4 is going to undo multiplying by 4. What happened to us? Come on. We know that the 1/4 power is the 4th root. So I need to take this to the 4th power. When I have 1/4 exponent, that's the same as the 4th root. And if I want to undo the 4th root, I have to go to the 4th power. I got to take this to the 4th power, and I got to take this to the 4th power. Remember, whatever my power is, I can undo that power with the reciprocal power. So if I have the 1/4 power, I can undo it with the 4/1. If I had a 2/3 power, what would I undo 2/3 power with? A power of what? Not just 3/2. Okay, so I undo the 1/4 exponent with the 4th exponent. Those cancel each other out, and now I'm left with 5x squared minus 14 is equal to x to the 4th power. Or 4. I don't know where I wrote 14. It should just be 4. I just have a 4 there, and I had it the whole time, obviously. So. Okay, so I accidentally wrote 14, but it should just be 4. Nah. All right, so then now at this point, I have a higher degree. I have an exponent larger than 1 on an exponent, so that means I need to set it equal to 0. I'm going to set it equal to 0 by minusing 5x squared and then plusing 4x, or just 4. Okay, so now in particular, will require you to remember a lot of things from chapter 5. Specifically that if I have an exponent of 4 and then this middle term is an exponent half of this, I can treat this as if it was an exponent of 2 and an exponent of 1. Okay? But more particularly, we can follow the flow chart to factor this. Is there a greatest common factor? No, there is not. How many terms do I have? 3. I need to find my A, B, and C value, and then answer the question, does my A equal 1? There's my A, B, and C value. Does my A value equal 1? Yes. So I'm going to look for numbers that multiply to 4, but add to -5. What numbers multiply to +4, but add to -5? -1 and -4. Okay. So since this is the case, the only thing that's way different about this, because I have a 4th power, since it goes 4th power and then half of that in the middle, instead of x minus 4, x minus 4, x minus 1, it's going to be x squared minus 4, x squared minus 1. That's the only major difference between this and like a actual quadratic. We went over some problems like this in 5, but very briefly. It wasn't like a major part of the assignment. Okay, and so then now I got to look at each of these. They're each 2 terms. And they're each 2 terms, and I have to identify whether they're a special pattern. Special patterns call for difference or subtraction of perfect squares, subtraction of perfect cubes, or addition of cubes. Which ones do you think I'm going to look at? Squares or cubes? Squares, because I have x squared. So I have to find the root of each of these. Is x squared a perfect square? What's its root? X. Is 1 a perfect square? Yes, it is. 1 is a perfect square. What's its root? Is 4 a perfect square? What's its root? So all of these terms are perfect squares. So this means it's going to factor into x plus 1, x minus 1. That's factor in this. The root of x squared is x. The root of 1 is 1. Difference of squares, x plus 1, x minus 1. So the root of this one is x, and the root of this one is 2. So this factors into what? X minus 2 and x plus 2. Okay, so then now what do I do with all my factors? Got to set each of them equal to 0. So I have x plus 1 equals 0, x minus 1 equals 0, x plus 2 equals 0, x minus 2 equals 0. That means x is -1, x is +1, x is -2, and x is +2. So I get all those different answers. Then, specifically, I took this to a power, a variable to a power. I need to check for extraneous solutions. And you can plug this in one at a time. I think you can. I'll do one. I'll do 2 of these, but then after that, I'll just tell you which ones are extraneous. So I would have to go 5 times -1 squared minus 4 to the 1/4 power. And when I plug that in, I get +1, but it should equal -1. So this one is extraneous. And then here I can do the same thing, but with +1. And when I plug it in, I get 1, which is true on both sides. So this one's my true answer. 2 would also be a true answer, and -2 would also be an extraneous answer. Okay, that one is intentionally meant to be a little bit more difficult. Use some more prior knowledge that we've actually had. So that means it's a great problem. Any other problems that I can go over from 6-4? And that is from the gold sheet, the white sheet, and then also the handwritten problems on the back of the white sheet. There's just 2 of them. Anything else? So we're just good with the rest of that section then. The only thing that concerns me is that we started this problem off by nobody being able to tell me that the 1/4 power is undone by the 4th power. So I'm giving you the opportunity to get some more instruction on that. Right? Well, then some people are going to have to, you know, overcome their shyness. Otherwise, I am going to move on and just kind of assume that we're good. Okay. All right, let's start today's lesson. Today's lesson is going to be all about using other function operations that we've dealt with in the past and applying them to all different math operations that we've been doing throughout this chapter and prior chapters. So we're going to perform function operations with one learning target, building functions using addition, subtraction, multiplication, and division. All 4 of those, in my opinion, should be quite easy because it's doing the same thing that we've already done a million times in the past. The one that's going to be brand new is composition of functions. That's the one that's going to have, you've probably just never seen anything quite like it yet, okay? Which should make you guys all very excited. So, all right. Learning target 8 is that you can build functions using your 4 main additions and then also composition of functions. Let's say I have 2 functions, f of x and g of x. And they're each defined individually. So I know f of x is defined as 3 times the square root of x. And g of x is defined by -10 times the square root of x. And I want to find what f plus g of x is. Remember, when I have a function, f of x, it's strictly just function named f, and it's defined by some math operation. I have another one named g. Okay, so they don't really tell you anything specific about what to do. But if I have f plus g of x, you are going to find f plus g of x by taking what f of x is equal to and adding it to whatever g of x is equal to. So I know that, just say on my desk. So I know that f of x is what? What is f of x? Okay, 3 times the square root of x. And I'm adding to it g, which is -10 times the square root of x. Now, the one part in this lesson where we normally would talk about this is actually in 6.2, but we kind of glossed over it because I knew we would come back to it. You don't have to write this down. But if I have something like this, if the radicals are the same, this is no different than doing this. If I take 3x plus -10x, that is -7x. I just got 3 plus -10. This is no different than this, but instead of x, I have the square root of x. So I can do the exact same thing. I'm going to take 3 plus -10 and get -7. But instead of -7x, I'm going to have -7 square roots of x. It's the exact same thing. Just instead of x, I have square root of x. And that would be true for cube roots, fourth roots, any roots. So the new function built from f of x and g of x, f plus g of x, is equal to -7 square roots of x. Do I have any questions about that? Like I said, I don't feel like adding, subtracting, multiplying, dividing should push our intellect too much here. Okay. We're going to evaluate a couple. You don't have to evaluate the next one when I have you do it, but when we evaluate these, you will have to do a little bit of that, but nothing too much. Evaluate the sum when x equals 4. That means just find what f plus g of 4 is. Meaning, take the function f plus g of x and replace all x's with 4. Square root of 4 is 2. 7 times 2 is negative 14. So f plus g of 4 is negative 14. And that's the evaluation part. I'm really way more interested in, can you give me that? Questions about addition of functions? Okay, you do not have to evaluate. I know it says evaluate the sum when x is 16. Just go ahead and figure out what f plus g of x on a is real quick. And I'll freeze the screen and try. All right, so basically you have f of x is 5 square roots of x, g of x is negative 8 square roots of x, 5 plus negative 8 is negative 3. All right, questions about adding? All right, if you can figure adding out, I'm imagining subtraction is going to be pretty much the same. So the subtraction with those radical functions are going to work the same. But not every function we have has to be a radical function. It can also be polynomials like we have here. So if I want to find f minus g of x, okay, I can do the exact same thing. I know that f minus g of x is going to be take whatever f of x is and then subtract from it whatever g of x is. In this example, it just happens to be polynomials. Okay, it might not always. It could be subtraction of 5 square roots of x minus 2 square roots of x. And you tell me that that's 3 square roots of x. But you can do the exact same thing that we've done actually in past sections. We've already subtracted polynomials from each other. So if I have 3x to the third minus 2x squared minus 5, we know that I am going to take f of x, 3x cubed minus 2x squared plus 5. And I am going to subtract from it g of x, x cubed minus 3x squared plus 4x minus 2. Okay, so we've done problems exactly like this last chapter. I think even in chapter 4 also. So this is nothing new here. I'm just subtracting polynomials. I need to distribute a negative. So this is going to be 3x cubed minus 2x squared plus 5 minus x cubed plus 3x squared minus 4x plus 2. Just distribute a negative. Minusing positive x cubed is negative x cubed. Minusing the negative x, 3x squared is plus 3x squared. Minusing positive 4x is minusing 4x. Minusing negative 2 is positive. And then at that point, you just find the things that combine together. 3x cubed and negative x cubed is what? Negative 2x squared and positive 3x squared. Be 1x squared. Sure. This is just minus 4x because nothing pairs with that. So the function f minus g of x is just take whatever f is and minus whatever g is. And then simplify. And so if I wanted to evaluate when x is negative 2, I would just be looking for f minus g of -2. Which you can evaluate by hand if you want to. I, for the most part, don't ask for you to do that because I would not do that. So if I want to evaluate when x equals -2, that means I'm going to take what the function we built, f minus g of x, and replace all x's with -2. And that's how this function notation works. 2 times -2 to the third power plus -2 to the second power minus 4 times -2 plus 7. Hit enter and you get 3. Is there anything I can explain more on subtracting? At worst, I'm hoping this at least looks familiar. Okay. Do we need to go over B or can I move along? That was a very ecstatic move along. You guys normally have so much fun in this class, and yet here we are just staring at the wall. It's the energy I'm putting out. I'm having a good time. Yeah, well, I could see it. I could. Okay. You can't miss math. I mean, is it? You guys had like 5 of the last 8 days off, and you come in here with no energy. Unbelievable. Well, here's the thing that's promising, because I know that you guys, you're like adding, subtracting. It is what it is, but really, what we're all here for is multiplying functions, right? That's what I thought. Because when you're trying to build a function fg, sometimes they will not put a dot or anything between them. Just like when you have 2x against 2 multiplied by x. If I have fg of x, that means f times g of x. Okay, and if I have f times g of x, that means you're going to take what f of x is and multiply it by whatever g of x is. How incredibly fantastic. Because we know f of x is x squared. And g of x is the square root of x. Oh, I'm so glad you said that, because somebody said that in the last class. And actually, these don't cancel. Because, and I'm going to write this on a note card, don't feel. I know that if I take x squared and I square root it, that will cancel. Or if I have the square root of x and I square it, that will cancel. I'm actually just multiplying these two together. So they don't actually cancel each other out. So I still need to combine these into one x. Does that make sense to you, Michael? Okay. You can think, but we can actually condense these into one. And the way I can condense this into one is understand that x. I know you're excited about. I know you're really excited about square roots, but we want to. Okay. All right. So the square root of x, though, we do know that that has a particular exponent that goes with it. What exponent goes with the square root of x? Not quite. X to what power is the square root? The 1/2 power. Okay. And so then now, once I have reduced this to the square root of x as x to the 1/2 power, what we can do is we can use the product rule. Product rule written on the board. Keep your base, add the exponents. So let's pretend that you have no idea how to add your exponents. You would take 2 plus 1/2, and then reduce this into a fraction, half fraction, to get 5/2. So I would accept two answers here. X to the 5/2 power, or the 5/2 power is the same as the square root of x to the 5th power. Which is why when we talked about the 1/4 power earlier, it had me so concerned, because that is a huge fundamental concept of this chapter. It's understanding what a fraction exponent means and does. 5/2 would be square root to the 5th power. 1/2 is just a square root. All right, do I have any questions about this one? Hypothetically, on the test, I'm just saying, if it were to happen like this, it may or may not, I'm going to change C a little bit. What if it said g of x was x plus 2 and f of x was x squared minus 3x plus 2? And it wanted to find f times g of x. What would you do? That would be to factor. That would be to break these down into more factors. And remember, if this is what g of x is, this, and it wants me to find f times g of x. I'm going to have to take x plus 2 times x squared minus 3x plus 2. And yes, you would have to use the box method. Okay, so let's just finish this problem out. Okay, yeah, so this is, again, this is another thing that I've talked about. Like, just we talked about a radical function here, but that doesn't mean that we can't apply these same concepts to polynomials. It would require a 3x2 box. X times x squared, x times negative 3x, x times 2, 2 times x squared, 2 times negative 3x, 2 times 2 is 4. So if they give you two polynomials and asking you to multiply it, I mean, this is what you're going to have to do. You have like terms. So in this situation, it would be x to the 3rd minus x to the 2nd minus 4x plus 4. So f times g of x would be equal to this cubic function. Nope. Nope. Oh, with this problem, are we done? Yes. Now, if you wanted to factor this, yeah, you'd use the flow chart. But the thing is, if I factored it, I would literally end up going here right back to where I was already at. Okay. So not necessary. So actually, factoring is like dividing, technically. Okay. All right. Let's talk about what happens if you divide. And then we're going to talk about the new one. So if I'm going to divide, if I have f divided by g of x, you may have guessed. If you're going to take f divided by g of x, you're going to take what f of x is and divide it by what g of x is. So we're going to take f of x, which is 4x, and divide it by g of x, which is x to the 2/3 power. And now I actually have to do a little bit of division. This is 1 times x to the 2/3 power. So 4 divided by 1 is 4. And then x divided by x to the 2. When I just have an x, that's x to what power? 1. Does anybody remember what I have to do here when I divide? You do subtract your exponents. It's the quotient rule, which means you're going to subtract your exponents. Whatever your exponents are, you're going to have to subtract. So I'm going to have to go 1 minus 2/3. 1 minus 2/3 is 1/3. But if you don't know that, 1 minus 2/3 should give you 1/3. So this is 4 times x to the 1/3 power. 1/3 power is the same as what? The cube root. So this could also be written as 4 times the cube root of x. I would take either. So if I went to evaluate this, this needs to be 27. Evaluate this when this is 27. That's terribly written. I'm just going to rewrite it. F over G of 27. So I want to know when x is 27. Means I'm going to take 4 times the cube root of 27. Anybody know what the cube root of 27 is? 3. So this turns into 4 times 3. 4 times 3 is 12. Okay. So again, the first 4 math operations that you do from here is like really just not, it's not really anything new. It's a composition of functions that are going to be new. Okay, so I need everybody to refocus because this is the part that you're going to have no idea unless you've been taught it, okay? I don't think it's overly difficult, but you just, you got to pay attention, okay? All right, composition of functions. It is often going to look like fog, where this is going to be like an open circle, or golf with an open circle. That open circle means composition of functions, okay? So if I have f composed of g of x, f composed of g of x, that means you're going to take what f of x is, you're going to take what f of x is, and you're going to replace all the x's in f of x with what g of x is. You're going to replace all the x's in f of x with what g of x is. So for us, f of x is 3x. So I'm going to have 3 times what is g of x equal to? 2x squared. So all the x's in f are now going to be replaced with 2x squared. I'm basically just taking this thing here, and I'm going to replace all those little x's in it. So this would be f of 2x squared. So that means I'm going to have 3 times 2x squared. Again, it's not that it's overly complicated. I don't feel like it's overly complicated. It's just like most people are going to blindly look at this and be like, what is going on here? Well, what is 3 times 2x squared? 6x squared. So this would be 6x squared. So f composed of g is 6x squared for this example. Okay. Hypothetical situation. We're not going to use the E that's here. What if I am going to tell you that g of x is going to be 4x cubed minus 8, and f of x is going to be the cube root of x minus 3. Yeah, you have to be careful, okay? What if I want g composed of f? So g composed of f is not the same as f composed of g. If f composed of g, that means take g and put it in f. You're gonna, in this one, g composed of f is we're going to take f and plug it into g. So this is kind of the opposite. So we're going to take what this is and we're going to put it right there in that x. Okay. So this is going to be equal to g of f of x, which is going to be g of the cube root of x minus 3. Right. So you just have to pay attention to how it's written. This one is g composed of f, so we take f and put it into g. So what would this look like? This would look like 4 times the cube root of x minus 3 cubed, and then minus 8. What happens in a problem like this? Where I have the cube root, 4 times the cube root of x minus 3, and then the x being cubed, and then I minus 8. The cube root and the cube cancel out. So now I'm just left with 4 times x minus 3 minus 8. And then I can distribute 4 times x is 4x. 4 times negative 3 is negative 12. And then I just have to take negative 12 minus 8 and go 4x minus 20. Do I have any questions about composition of functions? Or how it gets plugged in? Yeah, we did 2 completely. Yep, I just, this is kind of a more basic one. And then this one's basically the same as this. So I decided to make one that is a little bit more complicated, but also hint, hint, wink, wink, more test friendly type of question. Yeah, I just did a completely new problem. We might as well just cross this one out. Yep. Yep. To me, this demonstrates not only some understanding about cube roots and cubing, but also is doing our new learning target and building a composition functions. Right. So I redefined f and g of x and then went. When you do your composition of function, it's going to look a lot more like this. Okay. Your word problem for the chapter is also going to be a composition of function problem. Okay. So let's go over that. Okay. So you'll have a word problem that will involve composition of functions. Okay. So I have a coupon for $10 off of the purchase at a hair salon. The salon also offers a discount off of your purchase. So we're going to let X be the total cost of the purchase. F of X is going to be X minus 10 is the cost of your purchase using the coupon. So I take my price, whatever it is, let's say it's $100, and I use my coupon. I plug in X into this function. I get 90, and this function means I'm paying $90 because I took $10 off of my total price. Does that make sense to everybody? Where g of x is going to be 0.85, which is actually a 15% cost reduction. Okay, so again, if this was $100, 15% of $100 is what? Do we know what 15%? But that would, yeah, 15% off would be 85. Okay, so that's where the 0.85 comes from. Okay, so that means if I plug x is 100 into this function, I'm paying $100. Okay, so let's figure out what g of f of x means, and then we'll also do f of g of x. Okay, first let's do g composed of f, which is g of f of x. So I'm going to take what g of x is, 0.85 times x, and instead of x, what am I going to write? What's replacing x in g? Nope, because g of x is 0.85x, x minus 10. So I have to replace this with x minus 10. Okay, and then I can simplify by distributing. So g of f of x is 0.85x minus $8.50. Does anybody think they understand what this means in the terms of the coupon and the 15% off? Because both are happening. $10 off and then also 15% off. I'm taking 15% off the total price, but so I'm taking 85% of whatever the total price is, but I'm also taking 15% off of this $10. So in this situation, am I actually getting $10 off my price? No, because in this situation, the 15% discount is happening last, AKA otherwise known as that $10 off is happening first. And I know it's happening first because if I look at this expression here, if you were to evaluate this, you're going to go 10, whatever the price is, minus 10 first, then multiply it by 0.85, order of operations, parentheses before multiplication. Okay, so in this situation, you're going to get 15% off of your price, but you're also going to get 15% off of the $10 gift card, as opposed to f composed of g. F composed of g means I'm going to take my f function and I'm going to replace all x's with what g is. So in red is me replacing x with g of x. I'm replacing x with g of x here. And that expression is simplified. So in this one, order of operations, it's going to have me do multiplication first. So in this one, your 15% discount your 15% discount is happening first. Then $10 off. And we can evaluate this and see which one's better by plugging in x is equal to 100. I'm just going to pull 100 out of the sky. We're going to say, hey, let's say my total bill was $100 at a hair salon, which is entirely too much money to get your haircut, unless you're getting like 10 people a haircut or something like that. It's pretty easy for me to get my haircut. I just show up and the same thing every time. But let's just say the bill is $100 for example purposes. I've got 0.85 times 100 minus $8.50. So G composed of F, when the 15% discount's happening last, okay, what I would do is I would just plug this in. 0.85 times 100 minus 8.5. I'm going to pay $76.50. Whereas opposed to this, in this situation, where they are gonna do that 15% off first and then take the $10 off. We're going to use X is equal to 100 also. It's going to be $75. So someday when you have gift cards and percent offage, like coupons or discounts or whatever you want, what do you want to happen? Do you want the discount to happen first and then the $10 off? Or do you want the $10 off and then the discount? You want the discount first, because if you would do the $10 off first, you're actually going to discount that amount of money you're having taken away. This is having 15% taken off, that free money that you got from